Welcome you all to the Spark Research YouTube channel. This is Dr. V. Chandra, Assistant Professor in the Department of ECE, and here is the another session. So this is actually the 8th session of this series. Here we are going to take the questions which has been asked in GATE 2026, and for GATE 2026 your organizing institute is IIT Guwahati, and we are talking about this particular course from this electronics and communication engineering, right? So here not only we are taking the questions from this GATE 2026, but also we will focus on the detailed analysis of the solutions. So if you are preparing for GATE 2027, then definitely these sessions will be very helpful for you. And in this session, we are going to take the questions from this particular course, that is signal and system. And this question particularly belongs to the Laplace transform. So let's take, here is the overview of the syllabus. Here you can see the syllabus like for this network signal and system. So currently we are going to focus the questions which is related to the signal and system. And if we look into the signal and system, so again signal system can be divided into the continuous and discrete. And here mostly like in this session now we are going to take the questions from the your Laplace transform. So here actually the Fourier transform is here in continuous time signal, so which is closely related to the Laplace transform as well, right? So let's take the question. So question is that Laplace transform of the signal xt is equal to u of t minus 2, and this is the symbol of the convolution. TUT is given by. So actually question is simply asking what is the Laplace transform of this x of t. That's all, right? And x of t, you can see that that contains the two parts. First part is the u of t minus 2. U is nothing, that is unit step, right? Unit step is like a step function is the continuous DC type of the currents, and your unit means the if magnitude is 1, and here the second part contains the TUT. So we have to use the find out the Laplace transform. So as per answer key, your answer D is correct, that is e to the power minus 2s divided by s key, right? So let's see the solutions. So how we'll find out the solutions? So first of all, one property, if you will remember, it will be very easy to solve the question. What is that property? So convolution in time domain will be the product, that is simple multiplication in frequency domain. So here we are going to simply find out in the frequency, that is S domain. So in S domain, nothing to do, simply multiply the instead of the convolution, simply multiply the product of you can take the product of the both particular functions. Okay, so let's take the individual functions. So first part is your the Laplace transform of ut minus a. So as per properties, you can find it. It will be equal to the e to the power minus s divided by s. Similarly, for second part, you can get the Laplace transform, that will be e to the power minus 2s by s. Now what to do? So like using not this is the first part only, actually this is the first part only. Here this is the property, and using this property you can get the Laplace transform of the first part, and for second part again you can use the property here. So for t your Laplace transform will be 1 over s square. So after getting the both Laplace transform, you can multiply, because in the frequency domain, like for TUT, your Laplace transform is e to the power minus 2s divided by s, that we got it from here. And your for TUT, your second part, your Laplace transform is 1 by s square. So finally you will get the x of s is equal to e to the power minus 2s divided by s cube. So that is your option, right? So let's take the some basic idea so that you can understand it in a better manner. So Laplace transform is nothing. So Laplace transform is very simple thing which will convert a time domain to S domain of any signal, right? So here see yt is in your time domain and here same function just in the frequency domain. So just representation is different, but the remaining same things are there, right? So how question is that how will you convert time domain to frequency domain? So two things, first multiply by e to the power minus st, and the second thing integrate it from 0 to infinity. So this is the Laplace transform, very simple, right? Here as for example, here is in the same function is in the time domain and same function is in the frequency domain. So if we'll convert this, you just in order to convert the this function, in order to take the Laplace transform of yt, just replace e to the power minus 2t, use from with this yt, and then you will get the y of s is equal to 1 over s by s plus 2. How can we solve the equation? So just I'm trying to get a solution for a one question. So question is that Laplace transform of 1. What will be the Laplace transform of unit 1, right? So here we are going to use the same formula. So Laplace transform just 1 into and e to the power minus st dt and integration of 0 to infinity. And if you further solve this, then you will get the what, your 1 by s, right? So for 1 you can get the Laplace transform of s, 1 by s. Similarly for 1 by s you can get the for t you can get the Laplace transform of 1 by s square, and remaining you can check. This is the just summary of the Laplace transform and very important table, so you can remember, right? In this question your that this is useful, and some properties are there. So one of the important properties is the time shifting property, right? So in the time shifting property, here whenever you are shifting in time, that is u of t minus 2, then it will multiply to the power minus ts, right? And then remaining will be fs as usual. And second property, check this convolution. So this is also important property. So convolution in time domain of two different functions will be the product of the two different functions fs gs in the frequency domain or s domain. So we are going to use both property in our solution. Okay. So here we have already discussed these solutions, but let me talk about it once again so that you can understand it in a better manner. So xt is given t u t minus 2 and t of u t. So the major idea that you have to use this convolution property. So convolution property means here see part 1 and part 2. So take the in the time domain, this is the convolution, but in frequency domain simply it will be the multiplication. So it will be easy to find the x of s, right, with using the frequency this convolution property. So let's find out this one in the frequency domain and this one in the frequency domain. So how will you find out? So here this is the u of t minus t, and if you want to convert into the s domain, then you can use this property u of t minus s. So you will get the the Laplace transform e to the power minus 2s by s. Similarly, another one is the ramp function, that is t ut, and so if you wanted to convert it in the Laplace transform, then you can use this property and you will get the finally 1 over s square. Without using property also you can solve it, right? And finally you can multiply both this one and this one here in order to get the x of s. So that is the final result. So option D is your correct option. Okay, thank you to join the sessions. Play today, stay healthy tomorrow, and learn for a lifetime.